Alright, this is chapter 4, section 8. We're talking about isosceles and equilateral triangles, so specific types of triangles. Your objective is to prove theorems about isosceles and equilateral triangles, and also to apply properties of these two types of triangles. Pause the video, write down your essential question. Don't forget to use your depth of knowledge chart to come up with the beginnings of your statements. Alright, I already talked about when I have an equilateral triangle, even if it's laid on its side, the leg that is not one of the two that are the same is always going to be your base. And because that's always going to be the base, these two, the ones that are the same length, are going to be your legs, or the triangle's legs. And then these two angles that are outside of the base, or that are sandwiching the base, are always going to be the base angles. So angle 2 and angle 1 are going to be the base angles. And then that third angle is always going to be your vertex angle. You need to know that so that you know what your questions are asking for and what the theorems and postulates are talking about. Alright, so here's your first isosceles triangle theorem. And these are, one is the converse of the other, so it's the flip or the backwards of the first one. So this first theorem, the isosceles triangle theorem, says that if I have an isosceles triangle where two sides are the same length, then the angles opposite those two sides, or your base angles, are also going to be congruent. The converse of that is, so now I'm going backwards, if I have two angles that are the same, then the sides opposite of those two angles are the same. So those sides are congruent. Not the same as the angle, but the same as each other. So if these two are the same, then I can say that these two distances are going to be the same. And sometimes it's called the base angles of an isosceles triangle are congruent. So here's your first example. It says the length of XY is 20 feet. And you need to explain why the length of YZ is also going to be 20 feet. Well, I know that this angle here, and I have this auxiliary line that's already drawn in for me, which is nice, is going to be 180, because 180 is a straight line, minus 140, because that much of it's already gotten used. The remainder is going to be that distance there. And 180 take away 140 leaves me with a 40-degree angle. Knowing that that's 40 degrees, this angle and this angle here, which is also labeled 40 degrees, says that those two are the same. And if those two are the same, then these are my two base angles. I can also conclude, or I can draw the conclusion, that these two distances are going to be the same. So YZ is also going to be 20 feet. And that's the explanation about why. Here's your next task. You need to find the measure of angle F. So this is the one that we're looking for. You know that the isosceles theorem says that if these two side lengths are the same, then that means angle D and angle F are going to be the same. So I can make that statement. The measure of angle F is going to be congruent to the measure of angle D. And so that we don't have to continue writing that, we're just going to say that those two things are going to be X. So I can say that the measure of angle F plus the measure of angle D plus the measure of angle E is going to equal 180 degrees. And now that I have all of that, I can substitute the different values that I have. So D and F, I don't know, but I've assigned X because I know that they are the same. And then E is 22 degrees, and that is going to equal 180. Well, if I add these two together because they're my like terms, I get 2x plus 22 equals 180. I can subtract 22 from both sides. That leaves me with 2x equals 158. And then still trying to isolate the variable, divide both sides by 2. I get x equals 79 degrees. So the measure of angle F is 79 degrees. You also know that the measure of angle D is 79 degrees because they're both the base angles. Alright, I believe this is your first corollary. So, and these are again inverses of each other. This first one says that if you have equilateral triangles, then they're also equiangular. And this is what you guys were trying to tell me earlier in the week when we were starting to talk about equilateral triangles. You were giving me the wrong name. One talks about angles, the other talks about sides. This corollary tells you that if all three sides are the same, then you can conclude that all three angles are going to be the same. This corollary is the inverse of that. So it says if I have triangles that are equiangular, then they're also equilateral. Which means if you know that all three angles are the same, then you can conclude that all three sides are the same. And that's what that says there. So here's your next task. It says that you need to find the value of x, and I have x is, or this angle L is 2x plus 32 degrees, and this is given information. All three sides of this triangle are the same, which means that it's equilateral. If I have an equilateral triangle, then I can conclude that all three angles are going to be the same. If all three angles are the same, and every angle, or if I sum up the angles in the triangle, it's going to be 180 degrees. And that means each one of these angles is 60 degrees. Which means that this 2x plus 32 is going to equal 60 degrees. Now that I have that equation, I can solve for the x. So if I subtract 32 from both sides, that gives me 2x equals 28. Divide both sides by 2, I get x equals 14, which is what I was trying to find. Alright, last one. It says the triangle NPO is equiangular. That means all three of these angles are the same. And then they want you to find the value of y. Y is in those two expressions. Well, if I know that all three angles are the same, then I can conclude that it's also equilateral, which means this side is the same as this one is the same as this one. Because both of these sides are congruent, I can set both of those expressions equal to each other. So I have 5y minus 6 is congruent to 4y plus 12. And then I can solve for y. So I subtract 4y from both sides. I get, that's a y. Y minus 6 is congruent to 12. Add 6 to both sides. That's gone. I get y, oh I'm sorry, this is supposed to be equal, not congruent, is equal to 6 plus 12 gives me 18. And that's what I was trying to find. Please make sure that you're watching the videos twice if you don't understand something that's going on. When you're done, write your summary. And if you have any questions after you've written the summary or you feel like your summary is incomplete, please put questions below and we can talk about them in class tomorrow when we do the review.